Liftoff ignition, and we have liftoff.
We had hoped that we could reach interstellar space. We reached that with Voyager 1, and we're about to reach it with Voyager 2.
The vast expanse of space has always been a mystery to mankind. While we can't journey billions of miles into the unknown, our space probes can. One of the most renowned of these space pioneers is NASA's Voyager 1, which has travelled further than any other man-made object. But what if this trusty spacecraft suddenly begins sending back bizarre signals from its current location? Could something be going terribly wrong out there in the depths of space? Or is Voyager 1 just doing its job by giving us crucial warnings about the mysteries that lie beyond? Join us on an extraordinary journey as we investigate Voyager 1's strange signals from a mind-boggling distance of 23 billion kilometers away. Imagine a world where ancient humans spent countless hours gazing at the moon, never dreaming that one day we would be able to land on its dusty surface. Now, thanks to the tireless work of brilliant scientists and engineers, space exploration has become a reality. With the help of companies like SpaceX and NASA, we're setting our sights even further with a mission to reach Mars. But despite our advances, there are still limits to what humans can achieve in space. That's where space probes come in, and of all the probes out there, none have been more faithful or groundbreaking than the Voyager missions. Voyager 1 in particular holds a special place in history as the first spacecraft to leave our solar system and venture into interstellar space. With Voyager 1 currently sending strange signals from 23.5 billion kilometers away, we must ask ourselves, what is it trying to tell us? Voyager 1 has been on the move for over 45 years and is currently hurtling through space at an astonishing speed of 38,000 miles per hour, or 17 kilometers per second, making it the fastest spacecraft to date. What started as a mission to explore the outer planets of our solar system has surpassed all expectations as the probe continues to send vital data back to Earth. In 2012, Voyager 1 achieved a significant milestone when it crossed into interstellar space, a record-breaking achievement that wasn't publicly announced until the following year. Voyager 1, the twin spacecraft that launched after Voyager 2, was the first to zip past the gassy giants Jupiter and Saturn, making a name for itself in the space exploration community. Decades later, the stunning images it captured are still used in textbooks by various media outlets. But what makes Voyager 1 truly unique is the golden record it carries, a compilation of music and sounds from Earth that was carefully selected by a team of scientists led by Carl Sagan. This record is designed to be played by any intelligent extraterrestrial beings that might come across it, serving as a sort of time capsule that represents our planet and its inhabitants. The record includes greetings in 55 languages, audio clips of nature sounds, and a star map pinpointing Earth's location. Let's not forget the eclectic mix of music genres on the record, from classical to Native American chants and even Chuck Berry's Johnny B. Good. But what's really mind-blowing is the attention to detail that NASA put into the record's design. There are image decoding instructions on the cover plate that instruct the alien listeners on how to properly view the 122 encoded images on the disc, and for any smart aliens out there, they can even determine how long the probe has been in space by examining the uranium-238 fragment attached to the main bus near the record for isotope ratios. Despite all these incredible features, there are some who worry that the Voyager disk could lead hostile aliens right to our doorstep. But that's not likely to happen anytime soon, as the Voyagers will be drifting in interstellar space for tens of thousands of years before reaching another star. And even if they do get discovered, it won't be for a very long time. One fascinating fact about the Voyagers is that they will persist in the cosmos, even after they have ceased to operate or broadcast signals. Since space lacks an atmosphere, the probes will never rust, and there are few objects for them to collide with in the interstellar void. Voyager 1 achieved one of the most remarkable feats in space exploration history with its grand tour, thanks to a rare planetary alignment that occurs once every 176 years. NASA's plan to send 2 probes past Jupiter, Saturn and Pluto, along with 2 others, was scaled back due to budget constraints, but the 2 Voyager spacecraft still accomplished an incredible amount. Voyager 2 flew by Jupiter, Saturn, Uranus and Neptune, while Voyager 1 stayed close to Jupiter and Saturn. Voyager 1 almost didn't make it off the ground, but it surpassed its twin by passing the main asteroid belt between Mars and Jupiter. Voyager 1 returned the first images of Jupiter's major moons, Io, Europa, Ganymede and Callisto, as well as Amalthea, and discovered that they were active worlds with their own fascinating characteristics. The probe also discovered a thin ring circling Jupiter, 2 new moons, Thebe and Metis, and returning stunning images of Saturn, including the F ring and Prometheus and Pandora, 2 new moons. Titan's close-up images revealed nothing but an orange haze, fueling years of speculation. But it wasn't until the mid-2000s that humanity discovered the truth, thanks to images captured from beneath the haze by the European Space Agency's Huygens atmospheric probe. Despite the end of its primary mission after the Saturn encounter, Voyager 1 wasn't ready for retirement yet. The focus shifted to tracking the craft as it raced toward interstellar space. Imagine a spaceship breaking free from the clutches of a giant bubble, the heliosphere, that the Sun had been blowing around itself. This is exactly what Voyager 1 did in August 2012, and the world learned about it the following year through a study published in the journal Science. Scientists made this groundbreaking discovery after analysing data from Voyager 1's plasma wave instrument, which had recorded a powerful solar eruption between April and May of 2013. Electrons near the spacecraft vibrated wildly, providing researchers with clues about the density of Voyager 1's surroundings. As it turned out, the density was higher than what was previously found inside the heliosphere, which sounds strange, but researchers explained that the electron density at the heliosphere's edge is significantly lower than at Earth's surface. The date when Voyager 1 finally left the heliosphere wasn't determined solely by electron oscillations though. The spacecraft's measurements of charged solar particles played a role in pinpointing the momentous occasion, which happened to coincide with the death of Neil Armstrong, the famed Apollo 11 astronaut. On that day, Voyager 1 detected a 1% decrease in these particles and a 9% increase in galactic cosmic rays, which originate outside the solar system. At that point, Voyager 1 was more than 11 billion miles away from the Sun, and NASA's Planetary Science Division owes a great deal of the pioneering work done by the Voyager probes. Thanks to the Voyager missions, we've been able to survey the universe in ways we never thought possible before. With their flybys, the Voyagers have helped us determine our research priorities and set new goals for exploring the cosmos. The Voyagers were also trailblazers when it came to the use of gravity assists, a technique that saves fuel and shortens the time it takes to reach faraway destinations in the outer solar system. Voyager 2 made use of this technique to visit Jupiter, Saturn, Uranus and Neptune, and since then many other missions have followed suit. Cassini, for instance, has become a master of the gravity assist, using it to reshape Saturn's largest moon Titan and provide us with new insights into the planet's many moons. In short, the Voyagers may have been the architects of the planetary science paradigm, but they have also inspired countless other missions to reach the stars. Furthermore, Voyager 1 has spilled some juicy details about the edge of the Sun in our solar system, revealing the mysteries that have surrounded the heliosphere since its discovery in the 1950s. As we know, our solar system is just a tiny speck nestled within the vast Milky Way galaxy, which is home to a whopping 100 billion stars. Lucky for us, the heliosphere acts as a bubble that shields us from the radiation that could have been catastrophic if we were exposed to it. The Sun constantly emits solar wind, which carries the Sun's magnetic field and protects us from the harmful galactic cosmic radiation emitted by other stars. Although radiation isn't always a bad thing, space radiation is a whole different story. Galactic cosmic radiation, or GCR, can strip electrons from atoms and accelerate nuclei to nearly the speed of light, causing serious harm. Luckily, Earth is protected by 3 layers: the heliosphere, the magnetosphere generated by the Earth's magnetic field, and the gases in the atmosphere. Unfortunately, astronauts traveling to the Moon or Mars won't have the same protection as we do on Earth. During the Sun's 11-year cycle, the heliosphere varies in size, inflating and deflating much like a balloon. It consists of 4 main parts, with the innermost layer housing the major planets in our solar system and the outermost layer being the termination shock. The heliosphere has 4 main components, with the major planets located in the innermost layer, where the solar wind travels at full speed, unaffected by outside pressure. Voyager 1 and the Interstellar Boundary Explorer, IBEX, have helped us to explore and map out the heliosphere's boundaries. IBEX, a small satellite orbiting Earth, detects and analyzes energetic neutral atoms, ENAs, that form when the interstellar medium and solar wind collide. By collecting a large number of ENAs, scientists can create a picture of the heliosphere from the inside out. Now get this, scientists recently made a fascinating discovery about the heliopause, the outermost layer of the heliosphere that marks the end of our solar system. They found that it underwent a rapid and dramatic change, which explains the significant time gap between the entrances of Voyager 1 and Voyager 2 into interstellar space. Voyager 1, the farthest human-made object from Earth, also picked up a strange hum coming from outside our solar system. Thanks to data collected by the spacecraft's plasma wave system, a Cornell University doctoral student and her colleagues described the drone as very faint and monotone, with a narrow bandwidth frequency. Although the researchers think that the continuous background noise may be caused by interstellar gas, they are not entirely sure and are exploring other possibilities, such as thermally excited plasma oscillations or quasi-thermal noise. The study also suggests that Voyager 1's discovery of the strange humming noise in interstellar space is just the beginning. According to the researchers, the persistence of the sound indicates that the spacecraft could potentially continue monitoring interstellar plasma density even without plasma shock events. Moreover, the researchers believe that the constant droning sound could hold valuable clues about the interaction between interstellar space and the heliopause. The PWS instrument detected disturbances in the gas caused by the Sun during Voyager 1's entry into interstellar space. However, it was during the periods between these eruptions that the researchers noticed the steady signature of the near vacuum. As senior author James Cord, an astronomy professor at Cornell, puts it, the interstellar medium is like quiet or gentle rain. Detecting a solar outburst is akin to detecting a lightning burst in a thunderstorm, and then it's back to quiet or gentle rain. What do you think about these new findings? Share your thoughts in the comments below.